So we are discussing in unit 2 the synthesis of mechanism. So till now we have completed the graphical method of synthesis of mechanism. So in that we have synthesized two types of mechanism. One is a 4-bar chain mechanism and another one is slider crank mechanism. So there are two types of graphical synthesis in function generation. One is a relative pole method and another one is inversion method. Okay, so in both method we have another two classifications like two position synthesis, three position synthesis. For example, in two position synthesis they will give you one input angle, one output angle. So in case of 4-bar chain mechanism, for example, in slider crank mechanism they will give one crank angle and one distance. Okay, the slider distance. If it is a three position synthesis, okay, for 4-bar chain mechanism they will give two input angle and two output angle. So output angle is denoted as theta and output angle is denoted as phi and input angle is denoted as theta. And if it is a slider crank mechanism they will give two crank angles and two slider distances, okay, the reciprocating distance. So we have seen some problems on graphical methods of synthesis of mechanism. So now we will move on to the analytical method. Analytical method or computer aided synthesis of mechanism. So it is computer aided, but we didn't use any programs. We will use the analytical methods only. Okay. So we are synthesizing the mechanisms using function generation. Okay, there are three classifications of synthesis of mechanism. One is the function generation and path generation. Third one is the motion generation. In function generation, we will decide what the moment of the input, okay, and what the moment of the output. For example, if we are using the slider crank mechanism, means the input motion is rotary motion and the output motion that we are desired is the reciprocation motion. Okay, that will be designed in the determined in the function generation. So next one is the path generation, in which so how the each link, okay, the each link should move in which manner, okay, whether it is a straight line or whether it is a circular path, okay, that has been decided in the path generation. And third one is the motion generation. So after deciding the function, after deciding the path at which the links has to move, okay, and third one is the motion generation, in which how each link should move from one place to another place or one position to another position. That is the motion generation. So in the first one is the function generation. See here, we are going to solve one equation for determining the length of each and every link. Okay, so consider a 4-bar chain mechanism. Here we have 4 links. That is, AB is the first link, and AB is the input link, and BC is the connecting rod or coupler, and CD is the output link. So as I said earlier, theta is the input angle. Okay, input link angle, and input link angle with respect to x, and phi is the output angle with respect to x-axis, and beta is the coupler angle or connecting rod angle with respect to x-axis. Okay, and here the AB is the input angle. Okay, so it will be a crank, and BC is the connecting rod, or we can call it as a coupler. Okay, and CD is the output link. Okay, it will be slider or rocker arm. Okay, so it will oscillate. Okay, the AB will rotate and DC or CD will oscillate. Okay, so here the A, B, C, D, which denotes the magnitude of the links. Magnitude of the link AB, BC, CD, and DA respectively. So let us see, small a is the magnitude of the link length of link AB, and D represents the length of link AD, and C represents the length of link CD. Okay, likewise, B represents the length of the link BC. So now we are going to formulate one equation to find out what could be the length of A, B, C, D, okay, etc. So by solving this equation, we will get we will get this final equation like d by a cos phi. We know d is the length of the link and a is also the length of the link AB. It's cos phi. Phi means the output angle. Then same d by c minus d by c cos theta. Theta means the input angle, input link angle, and a square minus b square plus c square plus d square by 2ac equal to cos theta minus phi equal to cos phi minus theta. So it will be anything, okay, cos theta minus phi or cos phi minus theta. So this equation is known as Freudenstein equation and can be written as k1 cos phi plus k2 cos theta plus k3 equal to cos theta minus phi. So which means here k1 means d by a. So here you can see this k by a, d by a is written as k1 and minus d by c is written as k2. And so this entire term a square minus b square plus c square plus d square divided by 2ac. So this is written as k3. Okay, for simplification. So this equation is Freudenstein equation. Okay, for example, if three input angle is given means, so then we will have three Freudenstein equation. That is k1 cos phi 1, k2 cos phi 2, like that we will be having three equations. So see here, let the input and output are related by the input and output are related by some function such as y equal to f of x, and for the specified positions, so here you can see y equal to f of x. So this y is the output which is dependent on the x. X is the input. So here input is the angles. Okay, input angle. Okay, so it is dependent on the output is dependent on the input. For example, we are having three positions of the input link, that is theta 1, theta 2 and theta 3, and we have three output angles phi 1, phi 2 and phi 3. So it is required to find the values of A, B, C, D to form a four link mechanism giving the prescribed motion of the inputs and output links. Okay, so we have to find the length of or the magnitude of each link. That is a link AB, link BC, link CD, and link AD. So we have to find the magnitude of links. Okay, then only we can construct the four link mechanism. For constructing the four link mechanism, we need the proportions or the dimensions. Okay, so for finding out the proportions of link or dimensions, we are using the Freudenstein equation. Since we have three input positions of input link and three positions of output link, so we will be having three equations. Okay, so first equation is k1 cos phi 1. Here you can see phi 1 means this is the position, first position of input link and output link. Okay, so k2 cos theta 1 plus k3 cos theta 1 phi 1. So similarly, k1 cos phi 2. Phi 2 means this is the second output link angle. Okay, and k2 cos theta 2. This is theta 2 means second input link angle. Okay, plus k3 equal to cos theta 2 minus phi 2. So third equation will be k1 cos phi 3 plus k2 cos theta 3 plus k3 equal to cos theta 3 minus phi 3. So if you know the angle theta 1 equal to, for example, 30 degree, theta 2 45 degree, and theta 3 is 60 degree, means we can simply substitute these angles in this equation, and we will solve this equation by using the Gaussian elimination method or Kramer's rule. We will get the value of k1, k2 and k3. So let us see how to solve these three simultaneous equation. For example, if you know the solving of the simultaneous equation by using calculator, you can simply proceed that, or else you can use the Gaussian elimination method or Kramer by the Kramer's rule. Okay, so first, so from this equation, just construct the modulus. Okay, uh, matrix. So delta equal to modulus of cos phi 1, cos theta 1 and cos theta 1 minus phi 1. So you just take this row, sorry, this column, and take the second column and take the third column. Okay, so this will be the delta, and delta 1 will be, and the delta 1 and the delta 1 will be cos this column cos theta minus phi 1 and cos theta 1 and the 1 1 1, which means the k3. Okay, so k3 k3 k3, this is 1 1 1, so this is delta 1. And the third one, okay, delta 2 will be, just take cos phi 1, so this column, and cos theta 1 minus phi 1, so this column, the column, and third column will be k3 k3 k3, this column, this is delta 2. And delta 3 will be cos phi 1, so the first column and the second column and the last one. Okay, cos theta 1 minus phi 1, cos theta 2 minus phi 3. So by arranging these columns, okay, like that, we will get the four matrices. Okay, so by using the Gaussian elimination method or the Kramer's rule, we will be having the k1 value, k2 value, and k3 value. So we know that what is k1, k2, and k3. So k1 is the delta 1 by delta, or d by a, or k2 equal to delta 2 by delta, k3 equal to delta 3 by delta. Okay, so by solving this, we will be having the k1, that is d by a, k2 is equal to minus d by c, and k3 equal to a square minus b square plus d square minus plus d square divided by 2ac. Okay, so if for example, if we assume d equal to 1 unit, for example, if we assume d equal to 1 unit, we know the value of k1. Okay, so d equal to k1 into a. Okay, so we will get, or a equal to d by k1, so like that we will get the another value a. Okay, and here we know the value of k2, and we assumed the value of d, that is 1 unit, so we will get the value of c. So like that we will get the all the values, okay, a, b, c, and d. Okay, so we can construct the 4 bar chain mechanism. Okay, so we will solve. So we will solve one problem based on the Freudenstein equation. Okay, so first problem, design a 4-link mechanism to coordinate 3 positions of the input and the output link as follows. Here theta 1 equal to 20 degree, theta 2 equal to 35 degree, theta 3 equal to 50 degree. So theta means the input link angle, and phi 1, phi 2, phi 3, these are the 3 positions of the output link angle. Okay, that is 35 degree, 45 degree, 60 degree respectively. Okay, so we have to find the magnitude of each and every link. Okay, so since this is the 4-link mechanism, so here we have 4 links. Okay, so we have to find the magnitude of link AB, magnitude of the length of link BC, CD, and AD. Okay, so let us see how to solve or how to get the values of A, B, C, and D. Okay, since we know to get the ratios or the lengths of each and every link, we have to use the Freudenstein equation. Okay, so Freudenstein equation equal is k1 cos phi 1 plus k2 cos theta 1 plus k3 equal to cos theta 1 minus phi 1. Okay, since we have 3 input angles and 3 output angles, okay, so we will be having 3 Freudenstein equations. Okay, so we have constructed 3 Freudenstein equation. Okay, so we have to find the k1 value, k2 value, and k3 value. Okay, we have 3 simultaneous equation. Okay, to solve these 3 simultaneous equation, we can use the simple scientific calculator, or we can use the Kramer's rule or Gaussian elimination method. Okay, so first we will solve by using the Gaussian elimination method. Okay, so here delta equal to, so let us take the first column, the second column, and the third one. Okay, so if we take the modulus of the determination of this delta, we will be getting minus 0.00524. So this is the value of the determination of delta. Okay, so then the delta 1 is equal to take the this column, okay, this column, and take this column and the third column. Okay, so we will be having the delta 1 equal to minus 0.00333. So like that, the delta 2, that is a delta 2 and delta 3. So all these were solved, and we got the values of delta 2 and delta 3. Okay, then assuming, so here now we have found the values of k1, values of k2, and values of k3. So k1 equal to delta 1 divided by delta, and k2 equal to delta 2 divided by delta, and k3 is equal to delta 3 divided by delta. Okay, so we found the values of delta 1, delta 2, and sorry, k1, k2, and k3. Okay, since k1 we know that d by a, and k2 equal to minus d by c, and k3 equal to a square, k3 equal to a square minus b square plus c square plus d square divided by 2ac. Okay, since we have assumed 2ac, we have assumed, so we know the value of k1. Okay, that was found by the previous step, that is a delta 1 divided by delta, but we don't know the value of d and c. Okay, if you take any equation, so if there is only one unknown, means we can easily find out that value. Okay, but since here in this equation we have two unknowns, so we cannot find the um, answer. Okay, so we are assuming d as 1 unit. Okay, the 1 unit may be a 3 centimeter or 4 centimeter or 30 centimeter or anything. Okay, but we assume that d equal to 1 unit, because here the length is the proportion. Okay, with respect to some other link. Okay, length of the link. So k1 equal to d1 by a. So we know the value of k1, and we assumed the value of d, that is 1 unit. So a is equal to k1 into d. So a value is 1.56. For example, if d equal to 1, d equal to 3 means, or 2 means, then a equal to, so 1.56 into 2, which means 3 point something. Okay, 3 point something centimeter, or whatever the unit that you are taking. Okay, and k2 equal to minus d by c. So we know the value of k2, that is delta 2 divided by delta, and the d value was assumed as 1 unit. So we can easily find out what is the value of c. So here c equal to 1.33. So like previously, if you assume d equal to 5 centimeter or 50 centimeter, means then c will be 1.33 into 50 centimeter, or d equal to 5 centimeter, means c will be 1.33 into 5. Okay, so like that we will be getting the value of c. And the k3 value, okay, here k3 equal to a square minus b square plus c square plus d square divided by 2ac. Okay, so in this equation we know the value of k3, that is delta 3 divided by delta. By solving this equation we will be getting the k3 value, and we know the value of a, and we know the value of c, and we know the value of d. Okay, the only unknown in this equation is the b value. Okay, so from this, solving this equation, we will be getting b value. Okay, so here b value is equal to 0.66. Okay, so if d equal to 1 unit, which means I am taking 1 unit as 50 centimeter. 1 unit as 50 centimeter, means then b is equal to 0.66 into 50 centimeter. Okay, so like that we will be getting the value of the magnitude, length of the link AB, BC, CD, and AD. Okay, so now let us construct the actual diagram of the 4-bar link mechanism. Okay, so this is the actual diagram of the mechanism. Okay, what we have designed. Okay, so here we found the value of A, B, C, and D, and the input link angle and output link angle were given in the question itself. Okay, so first draw a straight line. Okay, draw a straight line of length D. Okay, so D was assumed as 1 unit. Okay, so construct a line, okay, of length D. Okay, D which is equal to D. So D may be a 5 centimeter or D may be 50 centimeter or anything. Okay, so it is assumed as 1 unit. Okay, so it is up to your wish. So you have to fix the unit. Okay, so 5 centimeter or 50 centimeter or 1 meter or anything. Okay, then we know the value of A, B, C, and D, and the input link angle were given. Okay, so first position, there is input link angle is theta 1 equal to 20 degree. Okay, so draw a 20-degree line, okay, of length A. Okay, so here A equal to 1.56. Okay, so if D equal to 5 centimeter means then A will be 1.56 into 5. Okay, so we are drawing the line A of length of angle 20 degree of length 1.56 unit. Okay, then the output link angle is phi 1 equal to 35 degree. Okay, so from D draw a draw a line of length, that is equivalent to 1.33 unit, okay, of angle 35 degree. Okay, so I have drawn the line output link. Okay, so that is CD of angle 35 degree. Then connect, okay, by using your uh, by using your drafter or scale. Okay, just join the B and C. Okay, and we have to uh, join these two links at a distance of about 0.66. Okay, you just move your scale or you just move your drafter. Okay, at which point this 0.66 unit satisfies. Okay, so at that point we just draw a line. Okay, so I'm drawing the line BC. Okay, so I have completed the synthesis of 4-bar chain mechanism of the first position. Okay, first position, and then we have to draw the second position. So what could be the second position? Okay, and the second position angles were given in the question itself. Okay, here the theta 2 will be 35 degree. Okay, here you can see theta 2 equal to 35 degree. Okay, so from A, okay, make an angle of 35 degree and length is equal to A. Okay, so draw a line. Okay, so I am drawing a line from A. So that is the input angle. Okay, which is in the second position, the green color. Okay, and we have to draw the output link of angle 45 degree. Okay, that was given in the question. Length is equal to C. So I am constructing the output link. Then by using your drafter or scale, okay, make the BC, make the coupler or the connecting rod of length equal to 0.66 unit of B. Okay, so I'm completing the second position of the 4-bar link mechanism. Okay, and the third position, okay, the third position angle is given in the question, that is theta 3 equal to 50 degree. Okay, so here you can see the 50 degree. So from A, make an angle of 50 degree. Okay, and draw a line of length A. So I'm constructing the input link. So this is the input link. Okay, then from D, at point D, make an angle 60 degree, because the output link angle is 60 degree. Okay, 60 degree, and draw a output link, that is C, DC of length C. Then close this B and C. This is a coupler or connecting rod. Okay, so we have completed the three positions of the 4-bar chain mechanism. Okay, so in the 4-bar chain mechanism that is in the question, they will give the three positions. Okay, three input angles and three output link angle will be given, and we have to find out the magnitude of link AB, BC, CD, and AD. Okay, then we have to construct the actual mechanism. Okay, that is synthesis of mechanisms and its application in robotics. So we have completed what is type, number, and dimensional synthesis. Then what is function generation, what is path generation, what is two position synthesis of slider crank and rocker mechanism, what is three position synthesis, and what do you mean by precision positions, and what is structural error. Okay, so we have completed almost the 50% of unit. Okay. And the only topic that is left out is Chebychev phase. So now we are going to discuss what is Chebychev phase. Okay. So before that, let us clear about what is the structural error. The structural error is something, the difference between the desired motion. So what we are desired. Okay, the difference between the desired motion and the actual motion produced is known as structural error. For example, the 4-bar chain mechanism, okay, the desired motion of input will be the input is the rotary motion. Okay, the desired motion is the oscillation motion. Okay, so I mean the oscillation motion, the desired oscillation motion is between 20 degree to 70 degree. Okay, so this is the desired motion. But what we are getting is the motion, and the actual motion produced is known as the structural error. Okay, then tolerances in the length of links and bearing clearances is known as mechanical error. So we know what is tolerance. Okay, so we cannot produce any component of the actual size. Okay, so there will be some limit. Okay, from this point to this point. Like, uh, for example, we cannot turn, or we cannot produce exactly a 18 mm diameter shaft or a rod. Okay, so there will be plus or minus 0.05. So this is the tolerance limit. 0.5, or this could be not having the dimension, then it will be accepted. Okay, so the error resulting from tolerances in the length of links and bearing clearances is known as the mechanical error. Okay. So this is the Chebychev spacing for precision positions. So precision means the repeatability. It means a particular experiment. Okay, for the same 100 times, we should get the same values. Okay, that is the precision. Okay, so how well the desired and the actual values are closer. Okay, that is the precision. Okay, so precision is related with the repeatability. So even though it is not accuracy, but if all the values, okay, or closer means, then it will be a precision. Okay, so here you can see this is the y is the output, and the output is depend on the input, that is f of x, function of x. So this is the actual, or this is the desired path, that is a 45 degree, and this is the desired path. Okay, of what we are desired. Okay, but the actual path of the link or the coupler is this one. Okay, this this one. Okay, the waveform. So this is the actual. So the difference between the desired value and the actual produced motion, the desired motion and the actual produced motion, that is called as the structural error. Okay, so in function generation problems, the output is related to the input through a function y equal to f of x. Okay, the output y is equal to depend on or related to the function f of x. Okay, and it is required to obtain the dimensions of a linkage to satisfy this relationship. So, okay, the previously we discussed the Fordenston equation, which is used to find out the magnitude of links A, B, B, C, C, D, and A, D. Okay, so the dimensions what we have obtained must satisfy this relationship, that is y equal to f of x. In general, a linkage synthesis problems doesn't have the exact solution over its entire range of travel. Okay, like you have seen in the graph, there is a error, there is a structural error. Okay, we have designed the desired motion is different, and the actual motion that is produced was different. Okay, so we cannot produce or we cannot have the exact solution over the entire range of travel. However, it is usually possible to design a linkage which exactly satisfies the desired function at a few chosen positions known as the precision or accuracy points or positions. Okay, so like that, here you can see the pink color line, that is a desired motion, and the red color waveform, that is the actual motion. Okay, we cannot have the actual and desired coincide at all the points. Okay, but this may satisfy at some desired positions, like the first one is the point A, and this is the second point, and the third point, and fourth point. So all the entire travel, it coincides at the 4 points. Okay, these 4 points are known as the precision or accuracy points or positions. Okay, so it is assumed that the design deviates very slightly from the desired function between the precision positions, and that the deviation is within the acceptable limit. So here you can see the deviation is acceptable, which is closer to the acceptable limit. Okay, the difference between the function prescribed and the function produced by the design linkage is known as the structural error. Okay, the difference between the function produced and the function desired. Okay, it is known as the structural error. Okay, for most of the cases, this error may be about 3 to 4%. Okay, in most of the cases, the structural error will be 3 to 4%. Okay, so that is what you see in this graph. Okay, and the amount of structural error also depends on the choice of the precision points. Okay, so here we have 4 precision points. For example, if you need to have 7 or 8 precision points, then the structural error could be something different. Okay, the structural error could reduce. Okay, a judicious use of precision points greatly affects the structural errors. So if the number of precision points is increased, means then the structural error will come down. Okay, so if the number of precision point is very low, means then structural error will be very high. So see, here we have, so this is the desired motion, and this is the actual motion. So now we are having two. This is a one precision point and the second precision point, but the structural error is very high. So this is the structural error. Okay, so this structural error is very high. So if the number of precision point increases, means then the structural error will come down. Okay, so thus a set of precision points may be selected for the use in the synthesis of linkage, which can minimize the structural error, and a fair choice is provided by Chebychev spacing. So okay, for determining or for reducing the structural error only, we are using this Chebychev spacing for precision positions. Okay, for n accuracy positions in the range x0 xo less than or equal to x less than or equal to x n plus 1. So for this range, the Chebychev spacing is given by xi equal to, Chebychev spacing is given as xi equal to, or xj equal to x xi equal to 1 by 2 xn plus 1 plus x0 minus xn plus 1 plus x0 divided by 2 cos 2j minus 1 divided by 2n. Okay, so this is the equation, Chebychev spacing equation. Here j or I equal to 1 to up to n. Here n equal to number of precision positions. Okay, so this is the Chebychev position, Chebychev spacing, which is mainly used to find out the number of precision positions. Okay, and to minimize the structural error. Okay, so we will solve one problem based on the Chebychev spacing. So this is the equation of Chebychev spacing, that is xi equal to xn plus 1 plus x naught divided by 2 minus xn plus 1 minus x0 divided by 2 cos 2i minus 1 into pi divided by 2n, where n equal to number of precision positions, where I equal to 1, 2, 3 up to number of precision positions. Okay, for example, If it is desired to design a linkage to satisfy the function y equal to root x over the range 1 less than or equal to x less than or equal to 3 using three precision positions, then the three values of the x. So here they have given the function, that is output y equal to square root of x, and they have given the range, that is 1 less than or equal to x less than or equal to 3, which means here we have three precision positions. Okay, then the three values we have to find out, the three values, that is x less than or equal to x less than or equal to 3. So 1 to 3, that means three precision positions. Okay, so we have to find out the exact values of x. Okay, so x1 here, I equal to 1 2 3 up to n here. So x1 equal to, so substitute here xn plus 1, that is 3 plus 1 by 2 minus 3 minus 1 by 2 cos 2 minus 1 into pi divided by 2 into 3, because 2 into n, here n equal to 3. Okay, so 2 into 3. So by solving this, we will be getting 1.134, that is the value of first precision position. And the second precision position, so substitute the value in the same equation, that is equal to 2. So x2 equal to same 3 plus 1 by 2 minus 3 minus 1 by 2 cos 2 minus 1 into pi divided by 2 into 3 equal to 2. So here we are getting 2. Okay, so 2 is the second precision value, and x3. So substitute I equal to 3 in this equation. Okay, in this equation we will be getting 2.866. This is the third precision position. Okay, so we are getting x values, x1, x2, x3, three x values. So substitute these three x values in the function. Okay, that is y equal to square root of x. So you are getting three y values, that is y1 equal to 1.065, y2 equal to 1.414, and y3 equal to 1.693. So this question may be asked in the 2 marks. So this is the problem on Chebychev spacing and Fluidiston equation. Okay, so in this problem we are going to find out the three precision, or whatever the precision position they have asked us to find, as well as we are going to construct the four link mechanism. Okay, so design a four link mechanism. The motions of the input and the output links are governed by a function y equal to x power 1.5. So here they have given the function y equal to x power 1.5, and x varies from 1 to 4, which means 1 less than or equal to x less than or equal to 4. Okay, here x varies from 1 to 4. Assume theta to vary from 30 degree to 120 degree, and theta varies from 30 degree less than or equal to theta less than or equal to 120 degree. Okay, so theta varies from 30 degree to 120 degree, and phi varies from 60 degree to 130 degree. So 60 degree less than or equal to phi 130 degree. The length of the fixed link is 30 mm. So okay, for if you take any mechanism, okay, there will be one fixed link. Okay, then only it is known as the mechanism, or else it is a kinematic chain. Okay, so theta varies from 30 degree to 120 degree, and phi varies from 60 degree to 130 degree, and the length of the fixed link is 30 mm. Okay, so use Chebychev spacing of accuracy points. So we have to find out the theta 1 value, theta 2 value, theta 3 value, and phi 1 value, phi 2 value, phi 3 value, as well as the x1 value, x2 value, x3 value, and y1, y2, y3. So whatever the values, precision positions that we have to find out. Okay, so we know the Chebychev spacing. Okay, equation of Chebychev spacing, that is x1 equal xi equal to xn plus 1 plus x0 divided by 2 minus xn plus 1 minus x0. here theta 1 equal to 30 degree. That is theta s the formula for value theta 2 value and theta 3 value. Similarly, phi 1 value, phi 2 value, phi 3 value by calculating using this formula. That is the theta I. Okay, the I could be 1, 2 or 3 up to n. So theta I equal to theta S plus theta F minus theta S divided by XF minus XS into multiplied by XI minus XS. So here I equal to 1, 2, 3 up to n. Okay, so first we are going to find out theta 1 value. Okay, so theta S. So theta varies from 30 degree to 120 degree. So substitute theta S equal to 30 degree plus theta F. That is, it varies from 30 degree to 120 degree. So X, theta F equal to 120 degree minus theta S equal to 30 degree, and X varies from 1 to 4. Okay, 4 means the final. Okay, so 4 minus 1 into Xi value. Okay, so we have found out the Xi value. And here theta 1 is x1 value. X1 value is 1.2 minus xs. Xs means starting value. Okay, that is 1 equal to 36 degree. So theta 1 equal to 36 degree. And similarly, find out the theta 2 value and theta 3 value. And the formula for calculating the phi 1. So it's the same formula. That is a phi I equal to the starting value of phi plus phi f final value minus phi starting value divided by y final value of y and final value of s into yi minus ys. So substitute the value of phi s, phi f, yf and ys and yi value. Okay, here phi varies from 60 degree to 120 degree, and phi s equal to 60 degree plus phi f equal to 130 degree minus 60 degree minus yf, because y varies from 1 to 8. Okay, so 8 minus 1 into yi value 1.315 minus 1 equal to 63.2 degree. Okay, so like that you have to find out the value of phi 1, phi 2, phi 3. So here theta 2 value and phi 2 value has been found, and theta 3 and phi 3 value has been found. Now we got theta 1, that is the 3 input position angle theta 1, theta 2 and theta 3, and 3 output angle phi 1, phi 2 and phi 3. Okay, so with this we cannot construct the angle. Okay, we need the length of each link. Okay, so in this question they have given the length of the fixed link, that is 30 mm. Okay, so we have to find out the other three link lengths. Okay, so for finding out the link of the length, we are using the prudence equation. That is k1 into cos phi 1 plus k2 cos theta 1 plus k3 equal to cos theta 1 minus phi 1. Okay, so we have three positions, that is theta 1, theta 2, theta 3, and three output link angle phi 1, phi 2, phi 3. So we have three prudence equation. Okay, so by solving these three equations by using a scientific calculator or by Kramer's rule, we will be getting the k1, k2 and k3 values. Here k1 value 2.286, k2 value minus 1.98 and k3 value 1.2. 461. Okay, so if none of the length is given means we have to assume any one length. Okay, in the previous problem we assumed d equal to 1 unit, but in this problem they given the length of fixed length is 30 mm. Okay. So by fixing the d value, you can find out the a, b, and c value. So we know that k1 equal to d by a, and k2 equal to minus d by c, and k3 equal to a square minus b square a square minus b square plus c square plus d square divided by 2a 2bc. A square k3 equal to a square minus b square plus c square plus d square divided by 2ac. So this is the formula. We know the value of k1 and d value, so we can find out a value, that is 13.1 mm, and we know the value of k2 and d value, so we can find out the value of c. Okay, substitute the value of k3, a, c, and d, so we can find out the value of b. Okay, so now we got the value of a, b, c, and d. Okay, and the input values were found by the Chebychev spacing. Now let us construct the 4-bar chain, 4-bar link mechanism. So this is the actual mechanism. The fixed link length is given, that is the 30 mm. So this is the fixed link length, that is 30 mm. Okay, and the AB is the input link and C is the output link. Okay, the input link angle is 36 degree. Okay, the theta 1 value is 36 degree, and the length of AB is 13.1 mm. So this is 13.1 mm, and B is 26 point. So this length is 26.5 mm, and the output link length is 15.2 mm. Okay, and theta 1 value, theta 2 value, theta 3 value we know, and phi 1, phi 2, phi 3 we have found. Okay, so construct the first position. So this is the theta 1 value is 36 degree. So from point A, mark the 36 degree line and draw a line of length 13.6 mm. So like that, here point D, the output link angle is 53.2 degree, and the length is 15.2 mm. Okay, mark point C. Okay, now join the point B with C. So this is the coupler. This is the first position, and the second position. So this is the second position. Okay, then mark the 75. The theta 2 is 75 degree. Okay, so draw a line of angle 75 degree and length 13.1 mm at point A, and draw another line of angle 89.5, that is the output link angle of length 15.2 mm. Okay, now join these two lines, so we are getting the second position of 4-link mechanism. Okay, and the third position is this one. Okay, the theta 3 is 114 degree. Okay, of length 13.1 mm at point A, and at point D draw the output link of length 15.2 mm and the angle 124.1 mm, and join these 2 points, you are getting third the third position. Okay, so this is how you have to construct the 4-link mechanism by using the Chebychev spacing and two-dimensional equation.